Hello and namaste. My name is Brandon and welcome to the next video in my channel on basic statistics. If you are new to the channel, welcome. It's great to have you. If you are a returning viewer, it is great to have you back. If you like this video, please give it a thumbs up. Share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. Now that we are introduced, let's go ahead and get started. In this video, we're going to go into a software program called JMP, J-M-P, that is actually made by SAS. Now, this is not a tutorial on JMP, but JMP does have a great regression tool where you can go into your variables one by one and watch all the numbers change. And then you can automate that process with a single click of a button or a fully automated process where it does everything for you. So we're going to go in and I'm going to show you all three. This is not about JMP specifically, but the tool it has in it is great for teaching multiple regression. So let's hop into JMP and see how it works. So here we are in JMP. On the left-hand side of the screen, we have our data set. So we have price in thousands. That is our dependent variable or Y variable or target variable. And then square footage of the home, whether it's an exemplary school district or not, number of bathrooms, and the number of bedrooms. So I will point out that this is a slightly different from the previous video in that that video had bath and beds reversed somehow. The numbers didn't change, but the numbers underneath them went to the other. So all the numbers will work the same, but bath and beds will be switched. Just want to point that out. Now, to get to the interactive regression tool I like to use to teach, I'm going to go up to Analyze, Fit Model. Now, under the Y, I'm going to put price in thousands. That's our dependent variable, our target variable. Now for the other four variables, I can drag them or whatever else down to construct model effects. There they go. Now in the upper right under personality, I need to select Stepwise. So in JMP, all these techniques are called Stepwise. So forward selection, backward elimination, best subsets, and stepwise regression, they're all considered stepwise because they all are iterative. So don't let that confuse you. So I'm going to go ahead and click Run. And then this interactive tool shows up, which I really like. I'll put that on the right. So a few things to point out before we talk about these concepts. First thing is this stopping rule. Well, remember in regression, it will vacuum up every variable we throw at it, no matter how insignificant that variable might be. And of course, that can lead to overfitting and complex models. So we have a stopping rule that says, hey variable, if you don't meet this threshold, you don't get in the model. Now in that previous video, we used a p-value. So I'm going to change this to p-value threshold. We used a value of 0.05, so I'll change that for probability to enter. Now we're just going forward. We're doing forward regression, forward selection, so the probability to leave doesn't matter. So the next thing I want to point out is the SSE of 552777. Well, if you watched that previous video, you will remember that was our total sum of squares. So that was our SST. Well, if you look here under current estimates, we have not entered any of the variables yet. We'll do that here in a second. So under entered, nothing is checked. Well, if you go back up to SSE of 552777, in this case, our total sum of squares and our sum of squares due to error are the same. They are equivalent. And that is because we have not actually entered any variables into the model. Now, if we haven't entered any variables into the model, what is our best prediction? Well, it is the mean of the Y variable, of the target variable. Well, if you look under parameter for intercept, under estimate, you see it's 207.3. Well, what does 207.3 represent? Well, that is the mean price of all the houses in our data set. So if we were to take the mean of this column over here on the left under price in thousands, it would be 207.3 because it's in thousands. So the mean price of all these houses in our data set are $207.3 thousand. That's where that comes from. Now you also see there's no R square or anything like that because again, we haven't reduced the error because SST and SSE are the same because there are no variables in the model. All right, now what this tells us, if we look in the F ratio and the SS sum of squares column, this tells us what's going to happen if we were to enter a variable. Now if you'll notice, if we look at all four of our variables, for sum of squares, we can see that square footage is by far the highest. Don't let the decimal place fool you down here at the bottom. I don't like how they do this, where this is 1 decimal, this is 3. So you could easily think that this is 543,000, but it's not, it's 5,000. So the sum of squares for square footage is 336,000. For F ratio, it's 152. And you can see the probability here is very, very low. So what we can do is say, you know what? That vacuums up, that sort of grabs onto the model and reduces the error the most. Now that we have concluded that square footage will reduce the error the most of the 4 variables, we'll go ahead and click it. Now watch the F ratio for the other 3 variables and watch our summary up here at the top. So I'll click on square footage. Now a few things happened. Up here, our SSE went down to 216,537. That's a pretty big jump downward. We can see that now we do have an R square. With square footage alone, we've explained almost 61% of the variance in the dependent variable. See how that works? Now we continue this process. Look at the other 3 variables. We can see that those F ratios did change because now we have square footage in the model. So of these 3, we can see that bathrooms has the highest F ratio. It has a very low probability. So that's the one we will choose next. So I'll go ahead and hit bath. And now everything changes. So you can see that the F ratio changed for the other variables. Now our sum of squares due to error, or SSE, is down to 166,098. Our R square is now almost 0.70, 70% of the variance explained. So if I click off bath, back to where we were, we had a R square of 0.60 or 0.61. Click on bath. Now it's almost 0.7. And our SSE went down and our F ratios changed. So in the prior video, I said this is a living, breathing thing because everything reacts to everything else. And you can see that happening. So click off again. You can see that F ratios are 11, 29, 1.8. Click on bath again. Now the 29 didn't change because that's what we sort of locked in, but other things did change. See how this works? Now we do this step again. So remember, our probability to enter, or our threshold or stopping rule, is 0.05. So look at exemplary high school, F ratio 11.875. For number of bedrooms, we can see that the F ratio is very low. It's close to 1.5 approximately. And the probability is 0.22, which is well above 0.05. So of the 2 that are left, the only one we can enter is exemplary high school. Click on that. Now we can see that our F ratio for beds is 1.15 with a probability of 0.28, almost 29. So we can't go any further. This is it. So our sum of squares due to error is 147,814. Our R squared is 0.7326. Our adjusted is a bit lower because we account for the number of variables, but they're pretty close. So we can no longer enter any variables because the number of beds does not meet our stopping rule. And that's where we would stop with this model. Now what I'm going to do real quick is hit this remove all button. And that takes us back to where we started. Jump and other software programs can automate this process. All I have to do is hit step. It selects square footage. Hit step again. It selects bath, number of bathrooms. Hit step again. Exemplary high school. See how that works? Now if I hit step again, it won't let me. And it won't let me because the last variable here does not meet the criteria for our stopping rule. So I'm going to hit remove all again. Now I can just hit go, and we're done. Did the same thing. We can see that 76, approximately 11 and 30. If I remove all and go square footage, bath, exemplary high school, 76, 11, 30, same process. You can see how everything works here in this interactive tool, which is really, really cool. And we can do forward, backward, we can do stepwise, we can do best subsets. Use another tool here, and we'll get into that as we get into those other techniques. So I just wanted to show you this so you can see how the model is built step by step and how everything changes as we manually enter variables and why we decide to enter them or not enter them. And of course, the automated process by which Jump in this case does it for you. So we'll see you in the next video. Take care. Bye-bye.